Good morning, students. Welcome back to your mathematics class. Today the topic is substitution method of your integral calculus. Let us understand why this method technique is used in our integral calculus. Okay, students. Now I will be telling you to solve this particular problem, say 3x plus 2 dx. Then you will say, ma'am, this is a very easy problem. We can do it by using basic standard integrals. Then I will tell you, what about having a power of 2? You will say, ma'am, this is again easy. I will expand it and I will be doing this. Again, I will give it here 3 or 4. You will go on expanding. Isn't it? But if the particular thing goes to 20 or 200, then you will think about it. You will be expanding it with binomial expansion rule, and it will be giving you 21 terms. Similarly, the power goes on increasing. It is not possible for us, neither for you nor for me, to solve it, to expand it and then solve. So for this type of problems, we are using the very nice technique of substitution method. Substitution method is not a new term to all of you children. You have done it in differentiation, you have done it in limits and derivatives, isn't it? So in inverse trigonometry method also you have used a proper substitution to get your entire expression to a reduced form. So this is an introductory class to all of you for understanding in a well method of a substitution technique. How this is reducing my job, your job, let us understand that. Today I will be taking a general integrand. Say this one. And I am telling you to solve it. So definitely here it is an here it is t is equals to ax plus b. So our perspective here is to reduce this particular thing. So let us substitute this particular ax plus b as a new variable, say t. So let t be this. So changing into a changeover to another variable is not easy. Not only the particular term, I need to change here the dx part also. So for that, what we can do? So students, see, I hope it is understood. Differentiating both the sides. This is dt and this is a dx. B 0 constant number. So now we are ready. Let us move this a from this side to this side. Let it be 1 by a dt is equals to dx. I am going to substitute the entire material in the integrand. Correct? Now, after putting here, what my integrand is going to become now? Imagine here it is now t. So I am putting here t and the dx in the place of dx. It is dt by a. It is dt by a. So now it is becoming such a easy integration, isn't it? We need not to expand. We need not to think about expansion. So what it is? Here it was a n, correct? So t to the power of n integration means it will be n plus 1. So now children, this is n plus 1. This is n plus 1. This is again t. My aim is to convert the entire thing into a new variable t. But the ultimate answer must be given in what variable? The actual variable, that is x. So the changeover must be again done after you get the answer. So at last the formula, we are going to the answer we are going to get by using a proper substitution is ax plus b n plus 1 by n plus 1 and there is a 1 by a. What is this 1 by a comes from? By getting the derivative of the part ax plus b. So can we remember, can we learn it as a formula? We will be able to do it. It is going to make our job easier. You will find it a list of formulas of substitution integrals also. Okay, so like this, if it is sine, say sine ax plus b dx is there. We know the integration of sine x only is minus cos x plus c. But here, let us write down first minus cos of ax plus b. Because here with sine, the function here is ax plus b. So let it be cos ax plus b. Understood? Now in the denominator, please remember, let us understand, in the denominator, I am giving you a direct way. Like in the previous derivative also, you learned about the chain rule, but later on how you did it? You did it directly, isn't it? Have you always are you showing every time to the teacher what you are putting and what you are getting? Never, no? So here also the same thing. Just remember what to do in the denominator. You just write down the derivative of ax plus b. So here it is a and I am going to put a plus c. This is my answer. Now tell me children, I have told you how actually we are getting this formula and I am even telling you to learn them as a formula. But you must know the technique of doing it. That is what I am trying to teach you. I am trying to explain you. Let's take one more or two examples. Now, for example, this is so you can see the another problem here, secant square 7 minus 4x dx. Now you will definitely recall that what is the integration of secant square x? Yes, that is tan x. But here what we have inside secant square x? We have 7 minus 4x. So from the mother function integrand formula, I am going to write down tan of 7 minus 4x plus c. But in the denominator, don't you forget to write down the derivative of it. Okay children, how we are getting the derivative of it? By that method I taught you in the very beginning, by putting a proper substitution it to t. Okay, so I am going to put here a minus 4. What is minus 4? 0 minus 4 is the derivative in the denominator. So this is my answer. Correct. Let's see one more problem. The more you will solve it, the more you will get the answers. No. Now, a different type of one. Okay. Say tan x. What is the derivative? What is the integration of tan x dx? No, we don't have it in the previous standard integral formula. Why don't we have it? Because we are going to get it from the substitution method. That's why we are going to derive it from the substitution method. So tan x is sine by cos. Correct. Cos. Let us substitute cos as t. Let us substitute cos x as t. So if cos x is t, now tell me, what is the derivative? Please focus yourself into this part. I am putting my hands out of it. Please focus to this part. Cos x is t. So this is going to become almost dt. What is not there? This minus is not there. Let's bring a minus sign. So let's bring a dt here now. So what it is? Yes, this is integration of dt by t. But what is the value? Log t. Okay, so I'm going to write down here log t. So the integration of tan x dx becomes, what is t? I cannot stick my answer to t. Yes, I cannot. So what was t substituted as? So it is minus log cos x plus c. So I can so I am going to write this one as log of sec x plus c. Do you agree with the fact? This minus comes here. It will become 1 by cos x. So it is now log of sec x. So from now we are going to remember integration of tan x dx is log of sec x plus c or minus log cos x plus c. You all will try integration of cot x by putting cos by sine. Next one is also very interesting. See children, integration of sec x dx. Today see, using substitution, what we are doing? We are not doing major problems. We are only doing small problems, and I am showing you that how the substitution method is helping us. Okay. So sec x, it was also not in the list. Am I right? So let's find out that one. And here also we are going to take the help of substitution method, but later on. Before that, let me tell you one more small technique to do it. What I am going to do, you know, I am going to multiply the numerator and the denominator by a factor, as you can see, sec x plus tan x. Now how it is going to help me? See, when sec x is multiplied with this and with this, how the numerator will turn up? You will only tell me. First, let me substitute sec x plus tan x, say as u. Let the denominator be u. Then, what is the derivative of sec x? Tell me. It is sec x tan x. And what is this? So, and dx must be there. Please notice very carefully this one. Again I am telling you, the denominator tan x and the numerator is now the derivative of the denominator, that is sec x into sec x, that is sec x square x, sec x tan x, this is the same sec x tan x. So can I say, if this is u, then the numerator is du. Please do focus here. If this is u, can I say this is du? Yes, we can say. Now this entire thing is again going to become 1 by u du. See, this is again going to become 1 by u du. So, now this is log u this plus c. Okay, now what was u taken as? Sec x plus tan x plus c. So, this is my answer now. So, from now, we will learn the integration of sec x as log of sec x plus tan x. Only what I did here, I multiplied the numerator with sec x plus tan x and the denominator same by sec x plus tan x. So this is becoming this, and now I will give you a task. You will find out the integration of cosec x in the similar manner, but you have to find out what factors should be multiplied in the numerator and in the denominator. Okay, you will be finding it out. I will not tell you. And let us see one more last problem here in this particular video session. Say you have sine 2x dx and the denominator, and in the denominator I am going to give you a factor like this. Please look at the problem very carefully. Let us take the denominator. The denominator as t. Now you are going to find out the derivative of the denominator. Tell me what it is. It is going to become what? Are you going to get something out of the numerator also? Let us see that. So this is a square and the derivative of cos square x. I am going to write here 2 cos x minus sin x, but a minus is been put in the front. Okay. Now this one 2 b square sin x cos x, close it, a dx is equals to dt. What are you finding, my dear children? 2 cos x sin x. Whose formula is this? Sin 2x. 2 sin x cos x. Again, whose formula is this? Yes, sin 2x. So don't you think so that sin 2x is common out of it? So if it is common out of it, then the entire thing looks like this. I'm going to write that. Okay. So I'm writing here b square minus a square sin 2x dx is dt. Please focus on it. B square minus a square sin 2x dx is now dt. Do we have a b square minus a square here? No, we do not. So we do not have, but a do not can be removed by multiplying the numerator and the denominator by b square minus a square. So now this entire thing is now dt and this entire thing is t. So I'm going to erase this let part and I'm going to rewrite the integrand in a very simpler manner and by the using a very suitable substitution. I hope you are getting the concept very clearly now. We have different methodologies, different type of problems, but that is for later on. As an introductory class, I hope it is clear to very much to all of you that how this particular method is going to help us. Okay. So t, please do substitute the t value. What is t? You have taken the denominator. So in the place of t, you are going to write down a square cos square x plus b square sin square x. So this is the introductory part, few problems of substitution method. We will be carrying on with the particular method with different techniques, with different type of problems in our upcoming classes. So I want you to practice the small problems you have in your book in substitution method. Some study materials even will be provided to you for practicing more. So please keep on practicing standard integrals, keep on practicing substitution method. Every day you do lot of problems and I know you are doing. Please, and definitely this is an introductory class and in the next session you will be ready with the will be totally ready to learn more about it. Okay, so that's all for today. Have a good day, children.